Welcome back to Tech Pulse, your go-to show where we break down the latest breakthroughs in science and technology, making them not just digestible, but actually exciting. I'm Zaper.
And I'm Puck. Hey, before we dive in, don't forget to hit that subscribe button, drop a like, and, maybe even share us with a friend who secretly loves black holes but won't admit it.
Today's headline is a big one. Black hole collision confirms Einstein's and Hawking's predictions about space and time.
Okay, Zaper, let's slow down. Black holes, gravitational waves, Einstein, Hawking. That's a lot of brain power in one sentence. Can we break this down first?
Absolutely. So first, black holes. Imagine a region in space where gravity is so strong, nothing, not even light can escape. That's a black hole.
Basically, the universe's ultimate do-not-enter zone.
Exactly. Then we've got gravitational waves. These are ripples in space and time, predicted by Einstein's General Theory of Relativity over a century ago. Think of them like the ripples you see after tossing a stone into a pond, except the pond is space-time.
And when two giant black holes collide, boom, massive ripples.
Right. Now Hawking's piece, he predicted something called the Black Hole Area Theorem. In simple terms, the surface area of a black hole's event horizon, the point of no return, should never shrink, only grow.
Got it, like a cosmic one-way door that keeps getting bigger.
Perfect metaphor. And this latest detection gave scientists the clearest evidence yet that Hawking and Einstein were right.
All right, Zaper, headline decoded. What exactly happened?
On January 14, 2025, researchers detected gravitational waves from a black hole collision. They labeled it GW250114. It was the loudest gravitational wave event ever recorded, with a signal-to-noise ratio of 80.
Wait, signal to noise? You got to explain.
Sure. Basically, how clear the signal is compared to background noise. Most detections hover around 10 or 20. This was 80. Scientists said it was like hearing a whisper suddenly become a shout.
So the universe was yelling at us.
Exactly. Two black holes, each about 32 times the mass of our sun, collided roughly 1.3 billion light-years away.
Billion, with a B. That light took longer to get here than multicellular life has existed on Earth.
Right? And before the merger, the two black holes had a combined surface area of 240,000 square kilometers. That's about the size of Oregon.
Whistle. Okay, Oregon-sized black holes.
After merging, the resulting black hole surface area was 400,000 square kilometers, basically California size.
So Hawking's prediction checked out. Bigger after the merger.
Exactly. And the data was so strong, the team reported over 99% confidence, higher than previous tests, which were at about 95%.
This also ties into Einstein's General Relativity, right?
Spot on. The detection confirmed what's called the Kerr metric, a model of rotating black holes. Scientists even caught the ring-down phase.
Ring down? Like the black hole's victory lap?
Kind of. After two black holes merge, the new one vibrates like struck a bell. Those vibrations, ring down, let scientists measure properties like spin and mass.
And they confirmed that black holes can be fully described by just two numbers, mass and spin.
Exactly, which makes them deceptively simple despite being some of the most extreme objects in the universe.
Okay, so in human terms, you, me, we've got height, weight, personality, hair color, favorite pizza topping. Black holes, just mass and spin.
Yep, no pineapple on pizza debates for them.
Good. Universe saved.
Here's the cool part. This clarity wasn't possible a decade ago. The first gravitational wave detection was in 2015. Since then, LIGO and his partners upgraded massively. Now, they detect about one black hole merger every 3 days.
Every 3 days?
Yep, around 300 events so far. GW250114 was special because of how clear it was.
Like going from grainy VHS to 4K Ultra HD.
Exactly. In just days from now, we hit the 10th anniversary of the very first detection. Kip Thorne, one of the Nobel Prize winners behind LIGO, said Hawking would have loved seeing this proof.
That's kind of beautiful, actually.
So, to wrap this up, Einstein's equations still holding strong. Hawking's theorem? confirmed. And thanks to technology, we're peeking deeper into the universe than ever before.
And we'll keep bringing these cosmic updates to you without the jargon overload. Well, maybe just a little jargon.
That's all for today's episode of Tech Pulse. If you enjoyed this, hit like, drop a comment, and of course, subscribe so you never miss a moment of the future.
I'm Puck.
And I'm Zaper. Thanks for tuning in. See you next time on Tech Pulse.